In the basement laboratories and sterile clean rooms scattered across 3 nations, a technological arms race is unfolding that will determine which country controls the future of artificial intelligence, quantum computing, and military supremacy for the next 50 years. This isn't science fiction, but the very real semiconductor war between the United States and its ally Japan on one side, and China on the other, where the stakes are measured not in billions, but in global hegemony itself. Every smartphone, every data center, every weapons system, and every autonomous vehicle depends on these tiny silicon chips, making semiconductors the oil of the 21st century, except far more critical because they cannot be easily substituted or sourced from alternative suppliers when geopolitical tensions flare. The semiconductor industry has become the epicenter of one of the most consequential geopolitical struggles of our era, with the United States and Japan forming an increasingly robust alliance to maintain technological dominance against China's ambitious rise in chip-making capabilities. This contest fundamentally transformed from a trade dispute into an existential competition when policymakers in Washington realized that whoever controls advanced chip manufacturing controls the commanding heights of the global economy and possesses decisive military advantages. The complexity of modern semiconductors means that no single nation can dominate the entire supply chain, creating a situation where alliances become as important as individual technological capabilities. The origins of this chip war can be traced to China's Made in China 2025 initiative, which explicitly targeted semiconductors as a critical area where Beijing sought self-sufficiency and eventually global leadership. China currently imports more semiconductors than oil, spending over $300 billion annually on chips, creating an acute vulnerability that Chinese leaders view as a strategic weakness exploitable by adversaries. This dependency became painfully apparent when the United States began restricting Chinese access to advanced semiconductor technology, starting with targeted actions against telecommunications giant Huawei in 2019 and escalating dramatically in October 2022 with sweeping export controls that fundamentally altered the global semiconductor landscape. These restrictions prohibit American companies from selling advanced chips and chip-making equipment to China without licenses, while also preventing Chinese companies from accessing cutting-edge semiconductor manufacturing technology below 7 nanometers, effectively freezing China's progress at technology nodes that are now several generations behind the leading edge. The United States recognized that it could not counter China's semiconductor ambitions alone, given the highly specialized and globally distributed nature of the chip supply chain, where different countries control critical choke points. Japan emerged as America's most important partner in this technological coalition, bringing unique capabilities that make it indispensable to the semiconductor ecosystem. Japanese companies control approximately 30% of the global semiconductor equipment market and dominate the production of critical materials and components that no chipmaker can do without. Tokyo Electron produces essential etching and deposition equipment, while companies like Shin-Etsu Chemical and Sumco control roughly 60% of global silicon wafer production, the fundamental substrate upon which all chips are built. Japanese firms also manufacture the ultra-pure chemicals, photoresists, and specialty gases required in chip fabrication, materials so specialized that finding alternative suppliers would take years and billions in investment. The Taiwan Semiconductor Manufacturing Company, universally known as TSMC, sits at the absolute center of this geopolitical maelstrom as the world's most advanced chipmaker and the sole manufacturer of the most sophisticated processors that power everything from iPhones to advanced military systems. TSMC manufactures chips at the 3 nanometer node and is pushing toward 2 nanometers and beyond, representing manufacturing capabilities that neither China, the United States, nor any other country can currently replicate. The company produces chips for Apple, Nvidia, AMD, Qualcomm, and countless other American technology giants, making it arguably the most strategically important company on Earth. Taiwan's geographic location, just 100 miles from mainland China, combined with Beijing's stated intention to reunify Taiwan with the mainland, creates a nightmare scenario for American and Japanese strategists who recognize that Chinese control of TSMC would represent a catastrophic shift in the global balance of power. This vulnerability prompted the United States to essentially bribe TSMC into building advanced fabrication plants on American soil, offering over $10 billion in subsidies through the CHIPS Act to establish facilities in Arizona that will eventually produce chips at the 5-nanometer node and below. Japan pursued a similar strategy, convincing TSMC to build a fabrication plant in Kumamoto with substantial financial incentives and guarantees, a facility that opened in 2024 and represents Japan's determination to secure domestic access to advanced chip manufacturing. These moves reflect a broader trend called friendshoring, where the United States and its allies are deliberately restructuring supply chains to reduce dependence on potentially hostile nations and create redundancy in critical technologies. The Arizona and Kumamoto facilities also serve as insurance policies against a potential Chinese invasion of Taiwan, ensuring that TSMC's most advanced technology and technical personnel can continue operating even if the company's Taiwan operations were compromised or destroyed. Intel, once the unchallenged titan of the semiconductor industry, finds itself in a remarkable position of both weakness and strategic importance in this new landscape. The company that dominated chip-making for decades fell behind TSMC and Samsung in manufacturing technology, losing its ability to produce the most advanced processors and hemorrhaging market share to competitors using TSMC's foundries. However, Intel remains the only American company with advanced logic chip manufacturing capabilities and extensive expertise in cutting-edge fabrication technology, making it a critical asset in Washington's strategy to rebuild domestic semiconductor production. The United States government is investing billions through the CHIPS Act to revitalize Intel's manufacturing capabilities, viewing the company as essential to reducing American dependence on Asian chip production. Intel is building new fabrication facilities in Ohio, Arizona, and New Mexico, while also expanding its foundry services to manufacture chips designed by other companies, directly competing with TSMC in a business model shift that represents Intel's attempt to remain relevant in an industry it once dominated. Japan's role extends far beyond equipment and materials into a sophisticated strategy of technological containment that operates largely out of public view. Japanese companies maintain intricate relationships throughout Asia's semiconductor supply chain, relationships that American policymakers leverage to enforce export controls and technology restrictions on China. When the United States imposed restrictions on advanced chip technology exports to China, Japan quickly aligned its export control policies, recognizing both the strategic necessity of the alliance and the reality that Japanese companies cannot afford to be caught between competing American and Chinese demands. The Japanese government has also invested heavily in semiconductor research and development, allocating billions to ensure the country remains at the technological frontier in materials science, packaging technologies, and next-generation chip architectures. Tokyo views semiconductor independence not merely as an economic issue, but as a matter of national security, given Japan's complete dependence on imported energy and its resulting need to maintain technological advantages in high-value manufacturing. The alliance between Japanese suppliers and American chip designers creates a formidable barrier to Chinese advancement that Beijing struggles to overcome despite massive investments. Japanese equipment manufacturers have largely complied with restrictions on selling advanced lithography tools, deposition equipment, and etching systems to Chinese fabs, cutting off the technology transfers that allowed China to narrow the gap in previous decades. Companies like Tokyo Electron stopped selling their most advanced equipment to Chinese customers, while Japanese materials suppliers have carefully controlled the flow of critical inputs to ensure compliance with export restrictions. This coordination represents a significant diplomatic achievement for the United States, as Japan historically maintained a more conciliatory approach toward China given their extensive trade relationship and geographic proximity. The fact that Tokyo now actively participates in technological containment of its largest trading partner demonstrates how seriously Japanese policymakers view both the China threat and the importance of the American alliance. Chinese leaders recognize that breaking through this technological encirclement requires nothing less than building an entirely indigenous semiconductor ecosystem, from raw materials through equipment manufacturing to chip design and fabrication. Beijing has poured an estimated $150 billion into semiconductor development over the past decade through various industrial policies, subsidies, and state-directed investments, creating national champions like SMIC, Semiconductor Manufacturing International Corporation, which represents China's most advanced domestic chipmaker. SMIC has achieved production at the 7-nanometer node through innovative techniques that work around the lack of extreme ultraviolet lithography equipment, demonstrating impressive technical capabilities despite operating without access to the most advanced Western and Japanese technology. However, SMIC's processes require more steps, generate lower yields, and consume more power than equivalent TSMC processes, while the company remains completely unable to progress to 5-nanometer or 3-nanometer production without accessing restricted equipment. The technological choke point that matters most in this entire struggle is extreme ultraviolet lithography, a manufacturing technology so complex that only one company in the world can produce the necessary equipment. ASML, a Dutch company, manufactures EUV lithography machines that cost over $150 million each and represent perhaps the most sophisticated manufacturing equipment humanity has ever created, requiring components from thousands of suppliers across dozens of countries. These machines use lasers to generate plasma that emits extreme ultraviolet light, which then passes through mirrors polished to atomic-scale precision to project circuit patterns onto silicon wafers, enabling the tiny transistor sizes that define cutting-edge chips. Without EUV lithography, producing chips below 7 nanometers becomes extremely difficult and economically unviable, making ASML's machines an absolute requirement for advanced chip manufacturing. The United States successfully pressured the Netherlands to block ASML from selling EUV machines to China, creating what American officials view as an insurmountable barrier to Chinese advancement, though Beijing's researchers are desperately attempting to develop indigenous EUV capabilities. Japanese companies supply critical components for ASML's EUV machines, including specialized optics, lasers, and precision mechanical systems, creating another layer of allied control over this critical technology. This deep integration of Japanese suppliers into ASML's supply chain means that even if the Netherlands changed its export policy, Japan could still effectively veto EUV sales to China by restricting component exports. The result is a multi-layered system of technological denial that Beijing finds extraordinarily difficult to circumvent, as developing alternatives requires not just massive investment, but also decades of accumulated knowledge, specialized expertise, and the kind of international supplier relationships that China currently lacks. Chinese attempts to recruit Taiwanese and Korean engineers, steal intellectual property, and reverse engineer restricted equipment have yielded incremental progress, but nothing approaching the breakthrough that would allow Chinese fabs to compete with TSMC or Samsung at the leading edge. The economic implications of this chip war extend far beyond the semiconductor industry itself into virtually every sector of the modern economy. Restrictions on Chinese access to advanced chips have crippled Chinese artificial intelligence development, as training large language models and other AI systems requires the massive parallel processing power of advanced graphics processors that NVIDIA and AMD design and TSMC manufactures. Chinese technology giants like Alibaba, Baidu, and Tencent have stockpiled tens of thousands of advanced AI chips in anticipation of further restrictions. But these stockpiles will eventually become obsolete as American companies release more powerful next-generation processors that Chinese firms cannot access. The restrictions also severely handicap Chinese capabilities in supercomputing, where Chinese systems have dropped off the list of the world's fastest computers as they cannot access the advanced processors required to compete. Military applications represent perhaps the most consequential impact, as modern weapon systems increasingly depend on artificial intelligence, advanced sensors, and sophisticated computing that all require cutting-edge semiconductors China cannot produce domestically. The United States and Japan are not content with merely restricting Chinese access to existing technology, but are actively investing in next-generation semiconductor architectures that could obsolete current manufacturing paradigms entirely. Research into chiplets, where multiple smaller chips are combined into single packages, could reduce dependence on ever smaller transistor sizes and play to American strengths in chip design and packaging. Three-dimensional chip stacking, where processors and memory are integrated vertically rather than horizontally, represents another potential breakthrough that could bypass traditional scaling limitations. Quantum computing and photonic chips that use light instead of electricity to process information could revolutionize computing entirely, creating new technological frontiers where American and Japanese research leadership might prove decisive. Both governments are funding extensive research in these areas, viewing next-generation computing technologies as potential game-changers that could maintain Allied technological dominance even as traditional silicon scaling approaches physical limits. This semiconductor alliance between the United States and Japan represents more than just economic coordination, but rather a fundamental realignment of the global trading system towards strategic rather than purely economic considerations. For 3 decades after the Cold War ended, economic globalization proceeded on the assumption that trade interdependence would foster cooperation, and that maximizing efficiency through specialized supply chains served everyone's interests. The chip war demonstrates the definitive end of that era, as the United States and its allies now prioritize security of supply and technological advantage over cost optimization and efficiency. This shift imposes real economic costs, as moving chip production to the United States and Japan increases manufacturing expenses and reduces the economies of scale that made Taiwan and Korea such dominant producers. American and Japanese taxpayers are subsidizing this reshoring through tens of billions in government spending, representing a massive bet that technological independence justifies the economic inefficiency. The ultimate question is whether this allied strategy can actually contain Chinese semiconductor development or merely delay it while imposing significant costs on all parties. Optimists in Washington and Tokyo argue that the cumulative barriers created by export controls, supplier restrictions, and technological denial will prove insurmountable, forcing China to remain perpetually several generations behind the leading edge in chip manufacturing. They point to the fact that even with massive investments, China has made only limited progress in developing indigenous alternatives to restricted equipment and materials, suggesting that semiconductor manufacturing requires such specialized expertise and international cooperation that autarky remains impossible. Pessimists counter that Chinese determination, unlimited resources, and the historical pattern of technological diffusion suggest that Beijing will eventually overcome current barriers, though perhaps on a time frame measured in decades rather than years. They also warn that economic decoupling creates its own risks, as Chinese retaliation could cut off American and Japanese companies from the massive Chinese market, while Beijing's inevitable progress in lower-end chips could still disrupt global supply chains and undermine allied semiconductor companies' profitability. What remains certain is that semiconductors have emerged as the defining technology of the 21st century great power competition, with control over advanced chip manufacturing representing a prerequisite for economic prosperity, military effectiveness, and technological leadership. The alliance between the United States and Japan, built on American design capabilities, Japanese equipment and materials expertise, and TSMC's manufacturing excellence, currently holds decisive advantages in this struggle. Whether these advantages prove durable depends on the Allied ability to maintain technological progress, the resilience of current export control regimes, and ultimately whether economic and political systems organized around innovation and international cooperation can outpace authoritarian state capitalism focused on achieving semiconductor self-sufficiency. The outcome of this chip war will shape the global balance of power for generations, making every fabrication plant, every equipment sale, and every research breakthrough a battle in a larger contest that will determine whether the 21st century becomes an era of democratic technological leadership or witnesses the rise of a Chinese-dominated techno-authoritarian order.